Hello, in this video we're gonna create a structure for a Go project, a structure that will allow us to use certain modules as microservices if we like so. So for now we have this folder we create for this project. The project is basically using Go working space and will contain multiple modules that later can be used also as microservices. So we have first to initialize our main module, which actually will not be necessary. We'll rather use Go work init. This will create a file that will contain our current version of Go, and then we have to create our modules that can be used as microservices. So we have to create modules folder where we need for now certain modules like accounts, and let's say uploads. That's good for now. And besides the modules folder, we need a folder core that contains core functionality we need within the modules, like authentication or access to the database and so on. So we have these folders that will contain each module. For example, core, we need the core. We have to initialize it, go mod init, and we give the name of the whole project, core fetch. And then for our core folder we specify the name of its folder. So we have now the Go mod file with that name, and within our Go work we have to load that module by using the keyword use and the name of the module. So now this specifies that our workspace contains the core module, and also will have modules, accounts, and modules uploads. That will say have to be defined. We go in accounts, within the accounts, modules / accounts, say Go module, modules accounts. Same for uploads. So now we have these 3 modules specified in Go work file. We also need an entry point for our main project, and whatever we need to build as main file. So for main file we have to create also on the root a command folder where we specify our API application. The API application will contain our definition of the modules that we want to use within the main file. So this will be like package main. This is the main package, and this file will also contain the main function, and we want to be like server REST services that aggregates all the services we want to use, and we say use accounts service that we created in modules, and we also say use uploads service, and then HTTP listen and serve with the address specified from environment variables, and then for the listener we specify the services aggregator. So this is how the main file will be, and this will basically be like go build or run for now from our root folder of the project, or run command API main. And this file will contain the initialization of the services we want to include in our binary. Now, in order to make this working, we have to define our REST package that will handle the services. So that will have to be here in this folder. So we say REST, and also, as we said earlier, this module will handle also database connections. So we have now the database and REST folder, and within the REST folder we define rest.go. We also define jwt.go, JSON web token, that will be used for authentication. We also have to define authentication, and that's it. Or I think also that's it for now. We leave this for now, and we start with creating the REST code for the REST file. So we have package as we defined it, REST package. that will contain all the functionality for the REST API. Here we want to create, instead of a listener, like a standard listener that contains HTTP response writer, and HTTP request. Instead of a standard handler like that one, like this one, we have to create a listener like context, and we say REST context that will contain helper functions for the request, like access to the current user or other useful helpers. So we have to define the context. And the context will contain our response writer for the request, and the request. We also want to create a function, for a factory function, new context, with the parameters we need for context struct, and return a context. We also have to specify the return type of the factory function. So we have this context that we use for HTTP handlers, for REST API handlers. And for this implementation of the REST package, the actual functionality that which will handle the requests, it will be GoChi. This will be another layer beneath the REST package. So we have to import that. GoLang chi. So as we seen earlier, the core module contains the core folder is a module, as these accounts and uploads we defined in Go work file. So we have to include Chi library within the core module. So we include that package, and now we go back to this class now here, and we say, for example, for the context we define function like accessing the parameter of the URL, and we return Chi URL param. We give the request and the key, and that returns the parameter. We also need a function for accessing our current authenticated user. That returns the user ID of the user. And we also have to define some we leave this blank for now. We also have to define functions for accessing response writer if we need that. Has to be response writer. And also a function for request. And this one will return HTTP request, a pointer to that request. And we return the request. So we have this helper, we have the wrapper over the GoLang key. And as you see in command API main, there is REST services, which is a composite. We also have to define a package, composite package, composite functions within the REST package, and that we use for compositing the services. So let's define services struct that contains the chi router, the library we imported earlier, and the function services we used for composition, REST services. This function will return an instance to services that also creates an instance of chi router within the services. We also need a function, we also need a use function, and we say we define that function on services struct. And the service will be an instance of a service, like accounts or uploads, or whatever we want to create within the modules folder. So the chi router has a function mount that loads a specific HTTP handler on a specific route. So for this one, the route we define, we say server name that we have to define after this, and we specify the service. And this structure has to implement serve HTTP in order to use that as as a parameter within listen and serve. So that basically we have to implement a handler that contains this function. We say again S services, HTTP response writer, and the request HTTP request, and here we access our chi mux and say serve HTTP. So the composition is ready, and as you see here, it now points to the code that we created in Composite with the use functions. Says invalid type for the parameter. So now we have to create a service. We could create that in our REST package, where we have the context we receive in a handler for REST endpoint. So we define a type now for the REST handler. That is a function with that type, the context type we define here. So we have the REST handler, and now we have to define also a service. And we give a name for the service, a version, and an instance of the chmux. And for this structure, we also have to define a factory function, new service, name and version, that returns an instance of the service. So there is the name, version, and mux, which is an instance of chi new mux. So we have an instance of a service, and we could also add for this an endpoint for receiving the version. So now we have accounts and uploads ready to implement the service function. Before doing that, in order for the service, we could say class or structure to work with specific functions we need for the REST API. we need to implement those functions. Functions like get, post, and
It's
so on.
23 hours.
Get, post, and so on. Besides that, we also have to implement serve HTTP. Service serve HTTP response writer and request. And here we say smux serve HTTP, and this mux, for example, has specific functions we also need to implement. Get, add, patch, and so on. But we define the basic ones for now. This is only for abstracting the Qi library and creating our own implementation and usability functions we need. So let's start with get function. GoLang Qi basically expects as a second parameter a HTTP handle function, which is response writer and request. In our case, we expect a REST handler. This is how we also access in accounts or uploads when we define a service. For now, we have to register this handler, REST handler, in our Qi library as a handler for the pattern we define for the get request. So now this the get function from Qi library expects a HTTP handler func as we seen earlier, but we get here a REST handler. So for this to work, we have to create a wrapper function that wraps our handler and returns HTTP handler func. So let's define the wrapper function. So we have to return a handler func. And within the handler func, we say our handler, and we build new context. We can also create here, before executing a function, a checking mechanism to see if there is any any panic that occurs within the handlers from accounts and uploads we define afterwards. For now, let's define this function and we check if there is any panic with recover. And we could also verify if that is a specific error. Let's also log this message for now. Print and let's say write header HTTP status internal error. So we have the wrapper, and we can define other methods like post, delete, post, delete. We can also create a abstractization and use different frameworks instead of Qi. For now, this is good enough. So we have get, post, and delete. And let's define, let's use this code within our accounts service or module or microservice. Could be a microservice if that's but we will see this afterwards. So we define main file, or let's say accounts, package accounts, and we implement service function. And this goes like follows: service rest new service accounts version, and then we say service post here we need a handler, and the handler, as you can see, is rest handler. So we can create this one, just see how it feels. So we have the rest context that has the param function we created, the response writer and request, and also user, current user of the request. Let's leave this for now and let's create two more functions, one for authentication and another one for getting the current user, and we return our service. So now this is the implementation of the account service with register function, authentication function, and me function that retrieves the current user. For me function, we have to define a function for checking if for verifying that the request is authentic, the authorization header is passed to the request. So we can use like a function like rest guard out, and this guard out will provide the content for the user. So let's define this function in out. Package rest, and let's say func guard out rest handler. As you can see there, receives a rest handler and forwards a rest handler for the server for the GET request. So here in guard out we can also define a function for like we say guard scope, provide a scope like authentication, authentication or admin or different scopes of our based on our needs. Let's say scope, and next which is a rest handler. Let's define a scope here. Type scope string const scope out scope admin. And we say here return guard scope out and our handler, and we write our implementation in guard scope. So as you can see, the guard scope returns a rest handler. Return func. So returns this function, and here we have to validate our request. So let's create a different function. We say get out context. And this returns context, which is out context, and an error. And within guard scope, we say context error get out context, we verify our error and return unauthorized. So now usually you say response and write header. Instead of this, we can just use like status function, status unauthorized. So we have to implement this function in our REST package for the context. Say writer, write header, status code. Now we can use in authentication only status. Basically this is mostly like a wrapper. We have on top of GoChi for creating a structure that could be easy to read, easy to use for microservices. If we want that, for example, the accounts, we have the accounts, and this service we can define accounts command, and here within accounts we can create as follows: HTTP listen and serve. We specify a port and accounts service. So basically, if we now run accounts, we can run this separately, or we can build this separately as a service. Okay, let's return to authentication and go further and define and implement our get out context function. This function actually verifies if the query within the URL or access token exists or not. Usually there is we have to define actually in our context a query function and try to access our access token query. So let's define this function in the context as we did earlier for status. Query key. You say we get from the request URL query get key. So basically these are helper functions we define for our custom implementation on top of Chi library. So we look first for access token from the URL, and if that is empty, we try to get it from the header. We have to define a function also, header, and say authorization header. and let's say strings index any key, and we check if the authorization contains bearer, and see if that's there. So after bearer strings got prefix key bearer key equals with after bearer, and here we have our key from URL query or from authorization at header. We have to define also the header function, which, as I said earlier, is a helper on top of GoLang library. Header key and this returns from the request header get key. So we get the key from the request, and here we return context from key. Which we have to define in our JSON web token package rest. For to implement this functionality from JWT, we need a library for JSON web token encryption. For now, let's define our types and what we need to fulfill our dependencies in our authentication class, our authentication file. So we define out context that contains the user, contains the scope, contains the expire date of the token, and that instead of string must be at time. So we have the out context from key. So here, context from key, basically we decode our key that we receive from URL and we turn that into out context. So let's look for the library. GoLang JWT encoding. I'm looking for a specific library. Let's write there some keywords to point out to that library. Let's try to use this one and see if there is any example. Okay, let's see how this works. And try to install the library. And we need to install this in our core module. So we have installed this library, and now we have to import library and see what we have to use. JAWS, and there is a parse function. Parse sign. Key. And the second parameter I think is JAWS I think this one. Let's see if they have any example. There is no example, but let's see and try to test and see how this works. So we have parse sign. We give the key, which is the key we get from access token authorization, and we execute. We run the function context from key. We define here in GWT. So this function returns JSON web signature and error. Let's check the error. And for the object we have verify, which is a public key. Let's use from local defined variables, private key, public key, and define that here. Var private key, and say let's say generate.
It's 23:30.
So RSA generate key. Round over. RSA generate key. Round reader. And we say here how many bits for our key. So private key, we can create a private key with RSA generic key from crypto RSA, and we use the private key, public key for our verify. Verify returns data and error. If error, we verify the error, and then we have data which we can unmarshal and turn into out context. So this is our function, context from key. We used in authentication. And we also have to define here in this file, define a function create key, and we say context, out context, and which returns a key and an error. We leave this blank for now, and try to continue our guard scope function. So here we have the scope, authentication out context, which contains the expire date, the scope for the key, and the user ID. So we have to check if our key is expired or not. If our key is before now, we respond with status unauthorized. We also want to check if scope is our expected scope, and we return same status, and if everything goes well, we say next, and we execute the next function, which is from our accounts. Is the next function, and we set the scope. So we have here a scope which is string and expects this scope, which we can move the scope into the JWT and use it as a type. So we have guard scope, guard out, which gets the key from a URL and decodes the key into out context and verifies the key is expired or has this requested scope, which for guard out is scope out he used earlier in our me function guard out. Let's go back to GWT function file and create function create key. And we also have to create for this package, we have to create a test file and see it's working properly. So create key. Let's make some checks and verify if context user verify if context user is empty. If it's empty, expected user ID. You can also verify that for expire date. If expire after now, if not after now, return an error and say expected valid expiration time. Okay, so we verified the user and expiry date, and now we have to actually use the library we imported earlier for encoding and creating our key. So we have Joe's new signer, and here we say Joe's signing key. We have an algorithm. Joe's let's use as an algorithm this one I think we used previously. Let's try and see if that works. Oh no, it's different. Let's use that algorithm and then a key, which is private key. And then the second parameters are some options. We could I think leave nil. We have the signer, the error, check the error, and now we have to actually encode our out context into JSON. Context and after that we say signer sign date object and error. Again we verify the error and return and say object serialize, compact serialize, that returns a string and error that this function is defined with those two return types. Okay, we have the create key. We also have context from key, and we now want to create a test for this file, for GWT. So basically what we have to do is to create the context and encode the context, and then decode and see if we get the data we expected. Test create the context, hot context. We use to specify the user ID. We specify the scope and expiry date, which is time now, and we add time minute. We had changed 5 minutes. And let's say create key, context, and now check for any error. And try to use the other function, context from key, and we pass the key and we expect the context contain the data we need, which is the data we defined in our context. And say if out user not equal with context user, we do that also for scope. And see what we get. Unknown unsupported algorithm. So now I think we have to change the algorithm and use a different algorithm. And let's say with this one, which I know it works. Let's see if that works. And go to our test and run the test again. Yes, indeed, our GWT file works. So we have our authentication from core module, guard out function from it that we use for our account module. So now basically we can retrieve from the handler, we can retrieve the user based on that. So now we have to also go back to the user function and use our code we implemented. Get out context and say out context, and here we could use panic and say error not authorized, which we can define in sorry, my English is poor. Can define here in errors new not authorized. Otherwise, in return, we say out context return user. So basically, the user function, which is a wrapper on top of GoChi, will access the authorization token from request, from URL request or the header, and return out context based on that key we get from URL or header. So this is for now. We can test this. So we have the API. We delete the accounts for now, and we have API, and this should work. Accounts, and for uploads we can leave this blank for now and try to create a run, create a launcher, say working space folder, command API main from Go, and define the environment, listen, and the port we need for our listen function. This could be this is also helpful for debugging and things like that. Let's see if it runs. There is any error or something. We can test this by using a tool we need for requests, and let's say we defined account service, and there is post on account service. We can respond with something, let's say to write something on the response. You can create a function, and let's say hello world. We have to implement this function before going further. Context, right, a pass as a value of any type, and we also want to use status code, which is optional parameter. So we check status code and use context, right header, status code. Then we have to check if the data is byte array. write that to the response writer. We can also check if data is error, and write that error to our response. If the type is an object, we could encode that as JSON object. After this function, we can test and see if our code is working. We also have to specify header, content type for JSON, and finally write our bytes. So let's go back into main function. We have write hello world. I think we have to check for string also. Let return. Also, we have to specify content type, but for now, let's leave it like this and see what we get in our test. So we have HTTP, localhost, and accounts. As you could remember from compose, we mount with the service name. So we have the service accounts, and we use accounts /accounts, and in our accounts we have slash, so we don't need any other. Only, for example, for auth we have to use auth, but for main root, which is register, we don't need any other suffix. So let's see. Page not found. There is a post request. Page not found. Page not found. Let's see what's wrong. We have in main. We listen for that port. And server is the compose, which mounts service. We use the service accounts, and here we have accounts. Have the name, version. Let's check for the version. for a version and see if there is any response. There is localhost. I think this is the port. Listen. Let's try that and make sure we're listening on the right port. Okay, so this is there is HTTP localhost version. I think it's accounts version. So the endpoint version is working. We have to look in REST in our REST Go file and see post. Forget, post, and delete. Let's try again. Use post and accounts. Hello world. So it's working. Let's try to access me endpoint, and we have to, for me endpoint from the accounts module, there is guard out, and for this instead of hello world, this will return not authorized. This is a get request 401 unauthorized. We can use a breakpoint for this and see what is going when the guard out is triggered. So enter the guard scope. We have a scope out and our handler, which is from service func 3, which is this function. And we go further, get auth context from context, which is nil, and there is an error. Compact JSON format must have 3 parts. Basically, the error could be different here, and let's say if key is empty, return nil for out context, and an error specifying access token missing. Let's test that again and see if we get that error. Yes, access token missing, and enters and responds with status unauthorized. So to present a summary, we initialized a Go workspace with a core module and two modules, accounts and uploads. And within the core, we define our REST layer on top of
It's 0 hours.
GoChi. and we also created authentication for requests and composition for joining different services if we want to build one binary. Let's also look for database helper functions in this initial part of this video. Here is quite a few lines of code. For this project, we define our database helper functions, and we use MongoDB. And for this, we have to include our GoLang MongoDB native library. I think it's this one. Let's import this in core module. And create a function for a session that returns a database. We define the database connection URL. In environment variables. We have to create a configuration from Mongo options. And then connect. We check if there is any error on our connect. And we could also make a ping. And return the error. Panic there. We use panic if there is any error. We have ping, and now we have to get the database from the request. Basically, there is this session function with which we get the database instance, and then we can create a helper function for accessing a collection. And for now, I think this is what we need. And let's say in our module accounts, we can access and say database collection accounts insert one and so on. But we have to use these functions in a different package, so we also structure the accounts module as a separate microservice or service. This is all for now. In the next part, I will continue with implementation of accounts module, and try to make it functional with register, authentication, and me. We can also see how to implement a service like accounts by checking the channel videos and looking for Costco for creating account service in GoLang. That's it for now. Thank you for watching, and looking forward for the next part, where we create what we need for also creating microservice and try to improve the code base. Thank you. Looking forward, and please leave any comment below.